Bismillah ar-Rahman ar-Rahim. Students, we are going to solve this paper, June 2025, 31 variant and complete pure paper. So let's start. Question number 1. He's saying sketch this one. And when we have this condition comes inside modulus whatever, put equals to 0. 3 goes there and we got a 3 by 2 or it's 1.5. And best way, take this number in the middle and 3 values enough. 1.5 and one value before and one value after. So 0 and 2 is enough. So when I plug in 0 in this place, I get -3 modulus. -3 modulus will give us +3. And when I plug in 1.5 here, so it gives you 0. When I plug in 2 here, 2 to the 4 minus 1, so 1 modulus is 1. Now we are going to sketch because he asked us to sketch. Okay, because values are mostly coming in the positive section, so I will shift this line to here. Okay, student, let's start. So where's x0, y3? I'll count 1, 2, and 3. So this 1, this 2, this 3. Okay, 0, 3 is done. Now 1.50 is somewhere here in the middle. And x is 2, y1, 2 and 1. Sorry, 2 and 1 here. So I'm going to sketch. So Alhamdulillah Rabbil Alameen, this is nothing hard, Alhamdulillah, very easy. And let's go for next part for 2 marks. So this we can apply squaring identity. So we can do it this way, or we have another way as well, but I think so I do this way. I like this, do this way. So I'm going to do this way, and let's start squaring first term, 9x to power 2, 6x and plus 1. 4x to power 2, 12x plus 9. I'm getting 5x to power 2 plus 6x and minus 8. 5 8s are 40. 5 8s are 40 and 10 4s are 40. So 5x common, 4 common. We get x plus 2, 5x minus 4. Now we draw a bell shape. So this is our one number is coming. If you plug in this equal to 0, you got -2. This equal to 0, 4 upon 5. Because how to read lesser? Lesser means inside. So basically we have these values less upon 4 than 5, and x is more than -2 over 5. -2. So just to decide finally, we will check it because this diagram is drawn already. So this is not drawn. So I will make a table of two values because there is no modulus. There's no modulus left side, so 2 values enough. If modulus is there, then 3 values. I plug in 0. When I plug in 0, I got -1. I plug in 2. When I plug in 2, 2 to 6 minus 1, 5. So 5, okay, here. So I'm starting now x0 minus 1. x0 minus 1 is where? Hold on. x0 minus 1 is here. Okay, x0 minus y1. Okay, so 2, 5. Where's the 2, 5, 2 and 5 somewhere here? So we got 2, 3, 4 and 5. I'm using a scale, students, and so this is not like it is not examiner is not demanding from you this one. If you make it, no problem. If you don't make it, no problem at all. So this is done. You can see clearly the gap of this two lines are increasing gradually. It means they will not intersect, and only one intersection is here, which is less than 1. So I think the point is very clear. And we have done, and this is my answer. And this part we will ignore. So you learn one thing, whenever diagram is given, so you utilize the diagram and do it like this. But if diagram is not given, students, then we will take for example, some values less than 4.5 by 5, take any number and plug it in this equation. If satisfy, we take it and take this from this, any satisfy any number. For example, more than -2 is -1. You plug in -1 there. If satisfied, take it. Otherwise, ignore it. So this is a way. If diagram not given, then. But now it's very clear approach. Diagram is given, so I just have utilized the diagram to check my answer. So I hope so. The concept of the first question is completely clear. Question number 2, students, we have, and we have to get Q in terms of P. But whenever number before logarithm written, for example, before logarithm, we are bound to bring in power. Like ln P2 power 2. Here no number, so here no problem. But here I can take half in the power. Logarithm Q plus 1 to power half. Now I can combine, because no number, and no number. I can combine. How combine? P square time to P minus 1 and divided by Q to power root, or same thing. So half writing or root, same meanings. Okay, what identities are 3? We can write 3 and 3 into 1, and 1 we can replace by ln E, because ln E and 1 same, and 3 can go in the power. And ln cancel, and make sure this, for example, 2, you can write ln e to power 2, 5 ln e to power 5, k you can replace by ln e to power k even. This is done, students. So what I'm going to do, so first of all, I'm doing cross multiply. So I got e cube times 2 root q plus 1. Now, students, I will bring, there's a p square times 2p minus 1 over e cube. Q plus 1 square root. So first of all, switch the side, left become right and right becomes left. While switching, a single sign will change, make sure. Now how to remove this one? Roots are squaring both sides. So it means it will turn to be this form. And this one goes there, and this is our final answer. So e square and minus 1. So I hope so. Point is very clear. And we have done it. Question number 3, find the complex number z. If this is a real, it means it has a real part and imaginary part, we can say equal to 0. Okay, and this z modulus is root 17. We have to give answer in this form. So let's try to do it. First of all, best way, you plug in this value in both z values. So x plus iota y plus 5 iota, x plus iota y minus 5. Okay, according to situation, he said that it is real part, but is a complex part is 0, because clearly mentioned that is a real part. It has some, but imaginary part is nothing, 0. So let's complete it. First, I will rationalize it. So rationalization process is first of rearrange especially denominator. Upper part is not a problem, but I'm leaving as it is. Down part I'm rationalizing, but first I'm arranging the real part separate and complex part separate. And now I'm doing it now. So x minus 5 and x minus 5 minus iota y and minus iota y equal to a plus 0 iota. This you write or don't write, no problem. At the end, you can finalize the situation even, no problem at all. Upper part. So do it very carefully. This bracket, you write or you don't write, no problem at all. So this x into x, just a minute, please. 1 minute. 1 minute. How to, okay. Because I'm going to compare with this one. So best idea, I'm multiplying in the numerator only. What the logic behind will come to know. And I can say x into x, x square, x into minus 5, I got minus 5x. X into this, I'm getting negative iota xy. Now this time to this, I'm getting xy iota or iota xy. This into this minus 5y iota, or you can write before after, no problem. This into this negative iota square into y square even. Yeah, let me check iota square y. Yeah, this is done. Now this one, students, I'm writing plus 5x iota. What about this, students? Minus 25 iota. And last one, so negative 5 iota square y. This is lower upper part I have done. Lower part, I'm not doing any change. Okay, I'm not wasting time, or I can write even square of the 5 and plus square of the iota y whole square. This is also, and middle minus sign here. So, a square minus b square criteria, but upper part, because we know that we'll take only complex part, write a statement here um, let me write the wording. Yeah, as z, or you can say as it has real part only. No need write again, just we can write. So imaginary part equal to 0. So imaginary part is equals to 0. So I take I part only. Get ready. This is I part. I'm taking I part. So negative xy. Okay. Or I think the first I will cancel easily. So these two y value cancel out. Okay. And from here I got iota. So I'm getting here negative 5y from here. This iota square become positive. Real part I'm not taking. So this is I'm taking from here plus 5x. And then is iota also there. So negative 25. And is a real part I'm not taking. And equals to 0. Now divide by whole equation by 5. Okay, and I got a negative y plus x. Negative 25 is equals to 0. Okay, sorry, these are 5. Okay, now after this, what I'm going to do, rearrange. Okay, I make x subject or y subject, no issue at all. Basically, I got x minus y is equals to 5. Okay, this is no problem at all. Or I make it anything a subject. I make x subject. So I got a y plus 5. Equation number 1 done. Okay, so that is the reason I did not spend my time to simplify the denominator. Why? Because if I take the imaginary part, even the imaginary part have some denominator that will multiply with a 0. So that is why I did not waste my time to solve this one. If I solve even this part will multiply into 0, will eliminate simply. So that is why I save my time. Now, student, I did not utilize this one. Modulus of z equal to 17. So basically, x plus iota y is a z. So if I take a z modulus, it means root of x square plus y square. When I put this and this equals to each other, or put 17 root here, root cancel out, and I got x square plus y square equal to 17. So I'm writing here x square plus y square equal to 17. Equation number 2. Solve them simultaneously. And this x value I'm going to replace here. So y plus 5 whole square plus y square equal to 17. So let's complete. Squaring identity, y square plus 2 into first term, second term, 10y plus 25. Okay. So I'm getting 2y square plus 10y plus 10y, 10y and plus 8 is equals to 0. Let me recheck again. 2 5s are 10 and 25, correct, okay. 2y square and this becomes 7, 8, positive 8, correct, okay. Now divide by 2. 2 5s are 2 4s are. So factorization, 4 1s are 4. 5 common, I got 5 plus 4, 1 common, 5 plus 4. Okay, so this is clear, students. So I'm getting here y plus 4 and y plus 1 equal to 0. Two answers, which I'm going to write now here, which I'm going to write here. So these two answers. So y is equals to -1 and y is equals to -4. Now, students, we have to plug in this value here. So I will plug in there x is equals to -1 plus 5. So I'm getting here 4. So complex number x plus iota y, x value is 4 and it is a negative iota. This is my answer number 1. And when I plug in same this one, x is equals to -4 and plus 5, I'm getting x is equals to 1. So finally, x plus iota y, I'm looking for x is 1 and y is -4. So I'm writing here 1 minus 4 iota. I hope so. The concept of question is completely clear and we have done it. Alhamdulillah Rabbil Alameen. Question number 4, students, we have, and topic is differentiation. He said that parametric equations given, an equation of tangent we need to find at a point this and give in this form, and B M and C exact must be there. So let's try do it. And what's the way to do it? So let's try it. So first of all, so dx over dt. Reason left side x, right side t. That is y. Here dy over dt. Reason left side y, right side is t. Okay. Exponential function differentiation remains same. Copy as it is into the power differentiation. That is secant square t. Done. What about this one? So these are three criteria. First we deal power. 3 steps, sorry. Power, then we take a base. At the end, we do angle, top to bottom. So first, this power will go down and power 1 less. We got a 6 and 10 power square become 1 power. 1 power you write or you don't write, no problem. And now, base is a 10 and 10 differentiation is secant square. At the end, angle, an angle derivative is 1. So I have to simplify, then I can continue. Okay, I think this is a sine by cos and 1 by cos. I think so. We can see later on. First of all, he said that we have to find out first dy or dx. How to find? So by chain rule. Reason, whenever, look at in this question, x, y, and t. Whenever more than 2 variables involved, we always use chain rule. So check it. What is my job to find dy over dx? I will write two fractions always in this situation. dy comes in first numerator and dx goes in second denominator. What left behind? T. So dt comes in both here and here. Now this is same, student. This value remains same, no change at all. So I'm writing here 6 times to tan x tan t into cos square, okay, into secant square, sorry, secant square, I can bring it down later on. What is this one? Same, but only the flip form. So I will write 1 over e to power tan t into secant square t. And look at now, let's luckily cancel out. Okay, now what we get finally, e tan t, sorry, not e, only tan t, 6 tan t, sorry. 6 tan t over e to power tan t. So this is derivative is completely done. And now we said that replace. So we have to find what? We have to find what, students? He said that these points we had to plug in. So problem is only we have here t involved only. Here this e stand for x, e stand for x, and 3 stand for y. So can I plug in this 3 and y in the 3 and e here? Not at all. Not at all. So what is the solution we have? We have one solution only. Either put 3 inside here or 3 inputs in this. But I think so is plugging 3 is better. So I'm using here x is equals to, which I'm doing now here. So what is the equation I have? Basically, x is equal to e tan t. I'm replacing x is equal to 3. Sorry, x is equal to e. And let me go back, check. E, correct, okay. So I put e here, e equal to e to power tan t. So no power means 1. Same basis, I got y is 1 is equal to tan t. And when I take a tan inverse, why I take tan inverse? Is tan t match? Yes, match. I can replace both tan t by 1. So I'm saying here, so this gradient of tangent. So I'm replacing here 1, I'm replacing e to power 1. So I'm getting here the gradient becomes 6 by e. This is done. Now, students, equation of that one, tangent. Do you know, students, what is equation tangent formula? Y minus y1 m times 2x minus x1. So problems only with us is y and x. From where we get y and x? That is luckily given here, e and 3. I'm going to replace. Here I'm going to replace here 3 and here 6 by e. And here I'm replacing x1 is e. So we have to multiply 6 inside multiply. I got a 6 by e times 2x. And e cancel out and I get only 6. And final form, I got it here 6 by e times 2x and minus 3. And this is our final form. But because he was asking, give in exact form. So I hope so. The concept of the question is clear. Question number 5 and topic is polynomials. We can see, so this polynomial is denoted by f of x. Okay, so I can write easily f of x is equals to 3x to power 3 pa x square plus 7a to power 2x and q a to power 3. Okay. He's saying what he said in the question, he said p, q, a are constant, a cannot be equal to 0. F of x is divided by this. The remainder is this. It means when I plug in this equal to 0, students, this equal to 0, I will get what? X is equals to negative 2a. It means when I replace every x by negative 2a, you can see left-hand side and right-hand side. So because a lot of variables, so don't take risk and try to do attempt in one attempt. No, best idea, do step by step. 1-2 steps extra is good for your accuracy level. Okay, let me recheck. Negative 2a. I'm copying negative 2a. Yes, this is correct now. But he said his remainder is negative 22a cube. So I'm replacing it here. Negative 22a cube. Due to power 3, negative will come out. And 2 to the power 3, 8 3 is 24a. Due to power 2, this negative eliminates. So 2 square 4 and 4 p a square into a give us a cube. And here a cube I have missed. I'll clear now. Okay, what about this? Negative 7 to the 14 a cube and plus q a cube. Clearly we can see a cube dividing whole equation. So I'm getting here negative 22, negative 24 plus 4p, negative 14 plus q. And we have to make it equation in final form. So when I make a final form equations to students, what will happen? So 4p plus q. Okay, and now you can check it. So negative 22 plus 24 and plus 14. So I'm getting here 16. So equation number 1 is prepared. Let's go for next equation. Next he's saying that divided by this, the remainder is negative a cube. So again, I'm copying the function. All right. This time I'm putting according to the question. I will plug in this equal to 0. So 3x minus a is equal to 0. 3x is equals to a and x value is a over 3. Fractions, a lot of patience required, and remainder is negative a cube. Okay, so let's try do it. I'm replacing every x by negative, sorry, a by 3, a by 3. replacing every x a by 3. A by 3 cube, a by 3 square, and a by 3. Okay. And this replaced by negative a cube. So this is coming 27. So a cube by 9. So I'm getting here p a cube by 9. 7a cube by 3. And qa cube. So job number 1, divide by a cube. I'm getting negative 1 here. I'm getting 1 by 9. Here p by 9, 7 by 3, and q. So rearranging, but 9 is disturbing this 9 and 3. So LCM is 9. So multiply by 9. Negative 9, 1, p. So 3 7s are 21 and q. And finally, I got equation here. P plus q is equals to negative 9 already there, negative 1 and negative 21. So I'm getting here negative 31. So this is, I think so here, wait a minute. So this is, hold on, let me check. 3 square 9 and there 3 square and 9, 9. Yeah, 9 here. Look, 3, 9, 9 multiplying. So this is a 9q basically. So multiplying. So I got 9q. And here I'm getting here p plus 9q. So equation number 2 is done. I'm writing now here. Equation number 2 done. Now I have to solve them simultaneously, students. So I'm copying equation number 1 from here. And I'm pasting below. Okay. So what to do, students? Naturally, we can see here, I think I can multiply upper equation negative 4. So negative 4p, negative 36q, 4 ones are 4, 4 threes are 12, 4p copy and q copy equal to 16. This cancel out, negative 35q. And here 0, so 3 and 4, 140. So 140 divided by 35, we are getting 4. We are getting 4, negative 4. So q becomes negative 4. This negative 4, I can plug in any equation, I plug in it here. So 4p negative q negative 4 equal to 16, 20, 5. So Alhamdulillahi Rabbil Alameen, I hope so the concept of question is completely clear. Question number 6, students, we have a topic of complex numbers. And we have given Z1, Z2, and omega. Okay. And state the values of omega Z1. It means in short is multiplying these two complex numbers. And both are exponential forms. Okay. So, and first Z1 with omega and then Z2 with omega. So let's try to do it. W is Z1 is basically 3. And this one, pi by 4 iota times 2 exponential to power pi by 2 iota. And what is the basic criteria, students? In this option, we multiply the modulus outside. 3 2s are 6. But in the argument point of view, we add. So pi by 4 plus pi by 2. So we got a 1 over 4 plus 1 over 2. It becomes 3 pi by 2. 3 by 2. So 3 by 4, sorry. 3 pi by 4. So 3 pi by 4. Okay, 3 pi by 4 iota. Okay. Write iota before or after, no problem at all. But important part here, students, what is important here? Because, you know, this is also correct answer, but if you, because this 3 pi by 4, okay, pi by 4, no problem, it is the first quadrant, it is the second quadrant, sorry. 1 pi by 4, second pi by 4, and third pi by 4. So it means in this direction. If it's cross pi, then I will not take this direction. I will take this direction. So I will keep my eye on this point even. Luckily, this is in the second quadrant, so not a problem. Okay. So this is our final answer. So I hope so the point is clear. Let's talk about the second one, and that is W omega Z2. Omega is 2. Okay, I changed. Anyway, no problem. So 2 e to power pi by 2 iota times 2 3 by 2 e to power pi by 6 iota. So this multiply, when they multiply 2 to cancel, we get 3. We get a 3. Okay, and what about this? Pi by 2 and pi by 6. If I add 1 over 2 plus 1 over 6. So we get a basically 2 by 3, 2 pi by 3. So 2 pi by 3 we're getting, okay? So pi by 3 is what basically, students, is basically 60 degree, okay? But it's coming 2 times, so it means again it is the second quadrant, so not a problem. So again, I will not go for it. I will just write as it is. So 2 pi by 3 iota. So we got it, and pi, I wrote by pi is not written. Okay, so we have done it. Alhamdulillah Rabbil Alameen. Let's go next part. Okay, he's saying on a sketch argon diagram with the origin O and A, B, C, D, and Z1 is A, Z2 is B, omega Z1 is C, and omega Z2 is D. So we have to do all. And luckily we have all positions, but before I start, this is an exponential form. If you expand the bracket, I show once. Basically, what if I have this, student, let me tell you once, okay? If we have this one is exponential form. This outside, this is called modulus, and this is called argument. But how to write it? If I show in polar form, if I'm writing in polar form, so you can understand very clearly, I'm writing one time only, not again. Okay, so if you type this alone, just check in calculator, students, and make it read in mode, make sure. So 3 times 2 cos pi by 4. So you see this turned to be, is turned to be, is come, wait a minute. Okay, wait a minute. I'll check once again, because these points are important to note down. Basically, it's coming root 3 by 2. Okay, root 2 by 2. So 3 times 2 root 2 divided by 2. So I'm getting approximately this number is I'm getting here 2.1. And when I multiply with this, students, so it means one time I will type in calculator 3 cos pi by 4, and one time I'll type 3 sin pi by 4. So luckily here same value coming. So 2.1 iota. So this is one example. So I'm not going to type all and show this all function all here. So this I just type and I got Z1. So Z1 is 2.1 and 2.1. And what about other students? Okay. So I'm writing A. A coordinates is basically coming 2.1 and 2.1. And what is Z2? I can write directly now. And I type directly. How type directly? 3 by 2 and cos pi by 6. So 3 divided by 2 time 2 cos pi by 6. You can check in calculator, students, without showing the to examiner. So when you check it in calculator, you got a 1.5. 3 by 2 pi by 6. So you get a B coordinate is coming with us 1.5. And what about the other students? With about a sine, if you check it sine, so I'm getting here, sorry to say, not degree mode, radian mode, sorry, I need radian mode. So when I type it, I got this one 0.75, wait a minute, 0.75. What about the cos? I'm getting here 1.3, okay? So I think you're understanding. So AB, I got it, because very important for sketching. And C, what is C? Omega Z1. Omega Z1 is here. It means this one. Again, I will type, student, the same story. I'll type 3 and cos 3 by 4. So it is if I check it, 6 times 2 cos 3 times 2 pi divided by 4, I get a negative 4.2. And what about a y coordinate? So sine. So there's the same value but positive value, 4.2. Now last point left, student, that is a D coordinate. How do you get D coordinate? D is basically omega z2, which is here. So I'm going to type it now, 3 times 2 cos 2 pi by 3, 2 times 2 pi divided by 3. And I'm getting here negative 1.5. Negative 1.5, space problem, so I'm writing below. So D coordinate, I'm getting negative 1.5. And what about the other one, students? Sine. So 3 sine 2 pi by 3, I'm getting 2.6. So this roughly points, I got it, and I explained to you how to get these values, okay? So this point is clear. Now I'm going to sketch it. If you look at carefully, these two values are negative, okay? And two values are negative with us. And two values are positive. So let's start. Let's start. This is very important sketching, students. Okay. All right. Okay, let's start. Okay, now I just make roughly because sketching is roughly okay. No need to make accurate diagram. Okay, so if you look at here, students, so first of all, I'm going to make it A. A is where? A is this one, 2.1, 2.1. So I may just make it an idea. This one, this two, this one, this two, okay, then this 3, then this 4, and here 5. Okay, and above, same here, 1, then 2, then 3, then 4. So I think it is easy to make it 2.1, 2.1. So it is approximately, roughly I'm making here. No need to make accurate. This is a coordinate. Okay, and I label in a bracket is a Z1, so I can understand easily. A1 is a Z1, okay? Okay, that's B. B point is also a positive section. So I can write it 1.3, which is somewhere here, and 0.75 here somewhere. So I have this point here, somewhere here. So I'm writing B coordinate, I'm writing here Z2. Okay, this is clear. And let's talk about C. Negative 4.2, negative 4.2 is 1, 2, 3, 4, and above here 1, 2, 3, 4. So basically it is this and this somewhere here. So I'm marking it approximately here. I'm writing here C in a bracket. I'm writing is a C point. I'm writing omega Z1. Okay, this is done. Now where is a D? This one. Negative 1.5 is here in the middle and positive 2.6 here. So it means approximately here. Okay, I got a D coordinate and representing Y omega Z2. So I think all points are very clear. Okay, I just join them. This is not important to join, just sake of your understanding part number next. Okay, I just take a scale better and joining is not compulsory for part this one, but next part we need it. That is why I'm joining now. 2 points I have it. Now third. Okay, and the fourth. Okay, this is done, students. Now have a look now carefully. This is done. So now this line joining again, I repeat, not important for the part number next one. So C part is what state the geometrical effects multiplying Z1, Z2 by omega. So basically he's talk about the Z1 is shifting on omega Z1. So what is effect is coming on this line to this line. Okay, so that I have to discuss. And similarly, I can discuss the other part. So if you look at carefully, students, and you can see this is if you focus here, what is the angle between this to this? What is angle between this to this? Okay, and sorry, from A to this, clear? So because first we talk about Z1 is this. So Z1 is shifting on omega Z1. So if you look at carefully, what is this angle? This angle is pi by 2, anti-clockwise. How come? Check it. Even we can guess from here. What is this angle pi by 2? Okay. First we talk about the rotation part. So this first geometrical impact is coming here is with us very clear. We can say that rotation, it is a rotation, 90-degree anti-clockwise. 90-degree or say pi by 2 anti-clockwise. So first part is clear. Second geometrical effect or impact is what? And that is we can discuss about even we can focus here both times when you deal with this, okay, or we deal with this one. So when 2 is multiplying, what happens? So the complete what is called, for example, this 2 is multiplying, it is multiplying factor is just like enlargement. Okay, so this 2, when I multiply omega with a Z2 or Z1, so it is 2-time enlargement. So we can say here, and we can see even, so whatever this length and this double length is this, okay? So it is we can say here, the second impact is what here? Enlargement by scale factor is equal to 2. So it's very clear because the number tells itself. Okay, if you go up and check again, this is a rotation effect, pi by 2 and 90 degree. And what is this? Is called enlargement effect. And we have done it even in chapter of transformation when we multiply any number. So it is stretch also and enlargement as well. So we can say stretch as well, but it's an enlargement as well. We can say both are okay. And I hope so. The concept of the question is now at the end is clear. Question number 7, students, we have, and topic is trigonometry. We have to express this into this form. But how to do it? First, we have to expand this. Apply fundamental law. Fundamental law of sine is very clear. If you remember, A sine A plus B available in formula sheet. But I repeat again, sine A cos B plus cos A sine B. So this formula I'm going to implement on this bracket. So let's start. 5 in the bracket, I'm writing here sine x cos pi by 6 plus cos x into sine pi by 6 and minus 4 cos x outside available. So cos pi by 6, check in calculator in radian mode, make sure. And this is a so this is becoming cos 30 basically, and there's a root 3 by 2. So I'm writing root 3 by 2. So sine x in root 3 by 2. So this part is clear. Okay. So this is clear. And what is for after that? Sine, this is becoming half. Open the bracket. So I'm getting 5 root 3 by 2 sine x and 5 by 2 cos x and minus 4 cos x. And these two cos same. So these two fraction will take LCM. And 5 root 3 over 2 sine x. And if we check it, 5, 2 4s are 8 minus 3 by 2. Minus 3 divided by 2. It means minus 3 divided by 2 cos x. And now, student, I'm going to equate with this. And equal, what is that? Sine alpha, sine x. So I'm writing in a blue color, sine x cos alpha and negative sign. So negative here and cos x and sine alpha. Outside we have r. And this r multiply both. So I'm writing now, saving the time. I'm writing r here, I'm writing r here. Now I'm comparing both sides. So when I compare, sorry, so this sine same, okay. So r cos from here and this one. So I will take it r cos alpha equal to 5 root 3 divided by 2. Equation number 1. Now cos alpha gone and minus minus gone. So I can say clearly that what I'm getting after that? I'm getting r sine alpha is equal to 3 by 2, equation number 2. Now, students, if I square both equation 1 square plus 2 square and add them, so r square alpha plus r square alpha will become this form. And right hand side square of this number, so I got a 25 into 3 over 4 and plus here 9 over 4. And right hand side I actually square 75 5 over 4 and plus 9 over 4. I'm getting here 21. Do you know, students, what r square common inside cos square plus sine square, and that is equal to 1. So I'm writing r square directly. So r becomes root of 21 without any hesitation and no need to work out further. So root 21. After this, we can looking for alpha and look on top. We r is positive, that is why I taken positive only. And first quadrant I have to look for alpha, and he said alpha 3 dp. Okay, R exact alpha 3 dp. 3 dp means this I can plug in it here or here. So I put in 1. Root 21 into cos alpha is a 5 root 3 over 2. So cos alpha, so 5 root 3 over 2 root 21. And now there's a positive and cos positive is here and here. But I will take this only. So I will take cos inverse. So, okay. All right. So I'm typing in calculator and I'm getting here 0.33. Alpha is coming 0.333. What is that? 3s for what? 3 dp, he said. So we have answer, Alhamdulillah Rabbil Alamin, clear. But I will do one extra job. What is the extra job? I will plug in back in this whole equation, which I have it. I have a 5 sine x plus pi by 6 minus 4 cos x is equals to r root 21 and bracket sine is there. So sine times 2 x minus 0.33 and 3. This equation, because it's part number A, and definitely this is going to use in a next page. So cut from here and we are going to use a next page. So check it, students. First of all, I will paste here this very important connection. I have it, and I will write here by part A. Okay, check it, student. Is this left hand side is completely same, but slight difference only. What is slight difference? X replaced by 2 theta, X replaced by 2 theta, rest everything same. So replace X by 2 theta, both sides. Not even here, not even here, even here. So then I can say what? This completely replaced by this and equal to root 7. So I'm writing here, root 21 sine 2 theta minus 0.333 is equal to root 7. And now student, he said, give your answer correct 2 dp, 2 decimal places. So, and answer is 0 to pi. So first 2 quadrant only, we have to look. First 2 quadrant, cannot cross. So this is, I have taken this as a beta angle and sine inverse root 7 over root 21. So again, root 7 divided by root 21, and I will take a sine inverse of this. So basically, I have a sine positive here and here. So I am getting here beta value is 0.61615. Okay, 615. So 0.615 is here and 0.615 here. And students, after this, I will bring back this complete angle down. So I'm getting here 2 theta minus 0.333. So my first answer is this. Second answer is this. So I'm writing here 0.615 and pi minus 0.615. Okay. Now, what to do, students? Just for because maybe, when we talk about the questions, I put comma here because This is my first answer. This is my second answer. Maybe I'll check this is a third answer. How to get third answer? 2 pi plus this answer, which is here, 0.615. So I am writing here 2 pi plus just for confirmation. Maybe this out of range, in range, we can't say. Now, students, why 2 pi? Because one complete cycle. Now check it. This will add, and divide by 2. So let's do first answer. And plus 0.333 and divided by 2. My first answer is coming with me 0.47. So I think this part is clear, and let's go for next. Second one, students, I'm getting what? If you check it, pi minus 0.615 and plus 0.333 and divided by 2. I'm getting second answer 1.43 is also clear. That's the third point. Third point is 2 pi plus 0.615 and plus 0.333 and divided by 2. My answer is come 3.62. And we have to look about pi only, and pi value is 3.14. So this is crossing the boundary. So out of range. So we have two answers. Sometime this come in range even. So that is why just for assure our answer must maybe range or not. That is why I have finished. I hope so the concept of the question is completely clear. Question number 8, and topic is vectors, and he has given OA. You can see and OA and OB, and line passes through OA and A and B. So we find vector equation of line L1. So R is equals to OA plus lambda times 2AB. So OA is from here. So 2, no J, so 0, 4K. And AB, how to get AB, students? So AB formula, OB minus OA. So OB is here and OA is here. And here is the answer. OB is a 516 and 204. So I got a 3, 1, and 2. So this is confirmed equation of line L1. Now, what the next plan? He said L2 is this line, L1, L2 don't intersect, show it. So first of all, this line I will convert standard form. Not even this, the other one as well, standard form. How to convert standard form, students? You can see. Okay. So from here 2 and lambda multiply with that, add them. So 2 plus 3 lambda and 4 plus 2 lambda. So what about this same way? I can get it now here. So 2 from here and mu from here. And 1 from here and 2 mu from here. And 5 from here and plus 3 mu from there. Now, students, I'm going to put them equals to each other. So when I put them equal to R, short story. So I'm getting here 2 plus 3 lambda is equal to 2 plus mu. And lambda equals to 1 plus 2 mu. And 4 plus 2 lambda is equal to 5 plus 3 mu. We're going to get 3 equations, students. 2 cancel out. So 3 lambda and minus mu is equals to 0. Second equation is lambda minus 2 mu is equals to 1. And third and last equation, 2 lambda minus 3 mu is equals to 1. So equation 1, equation 2, equation 3. Now basically we'll solve them, any two equations, solve them simultaneously. For example, I'm solving 1, 2. And I will not use third equation. I will find lambda mu from the 1, 2. You can use any two, not 1, 1, 2, or you can 2, 3, or even 3, 1. So this multiply with a 2 and add them. So I'm going to multiply first equation with the 2 and subtract equation number 2. So 2, 3 is a 6 lambda and 2 mu is equals to 0. And below equation, no change. Now subtracting means sign changes. This cancel out. 5 lambda is equals to -1, and lambda value is -105. Okay, after this we go for uh, second y value. I mean lambda I got it, and mu value. So I'm going to plug in this. So when I plug in there, so basically mu is equal to 3 lambda. So mu is equal to -3/5. This is done, student. Now I'm going to check. What is checking per technique? Third equation I did not utilize up till now, so put in 3. If left, right match, they intersect. If don't match, they don't intersect. So 2 lambda minus 3 is equal to 1. So lambda value is 3. Oh, sorry, this is actually here. Yeah. Lambda value is -105, and mu value is a -305. Okay, is equals to 1. I got -205 and plus 9/5. So 9 plus 2 equals 7/5. 7/5 is not equals to 1. So don't intersect. So I hope so this part is very clear. And let's go for the next part of the same question. He said find the angle between L1 L2. So we will take both directions. Formula is B1 dot B2 is equal to B1 magnitude into B2 magnitude and the cos of the angle between them. So how to get a B1 B2? This is important here, students. And their magnitude comes here, and the angle. So B1, B2, basically both lambda coefficient and coefficient and there's a lambda coefficient 312. 312 and the mu coefficient is 123. Repeat, B1 is 312 and other one is 123. So beside of mu and beside of lambda is B1, B2. So I'm going to cut from here. Okay, and I'm pasting here. Okay, this is done. Now square of 3 is 9, square is 1, and square of 2 becomes 4. Square of 1 is 1, and 2 square 4 and 9. And here corresponding positions values, you will multiply and add them. So we got a 3 plus 2 plus 6. Here root 14, here also root 14 and cos theta. So here I got a 6 plus 5, 11, root 14, root become 14, it goes down. And cos inverse. So in degree or radian mode, no problem at all. Both are same. I'm doing in radian mode because my calculator already a radian mode due to the previous questions. So radian mode I'm getting here. So I'm getting here theta is equal to 0.667 radians. I believe the point is very clear and question is completely over. Question number 9, and this is a integration by parts and involved in a numerical solution. So I have to convert this to this form. Okay, so let's start. First of all, I am just changing the arrangement. Log x before and 6x later. You may ask reason. Reason is here. L-A-T-E, late. E for exponential. T for trigonometry, I mean sine cos. A for algebra. L for logarithm, and I for inverse, and then end. Like a sine inverse, tan inverse. So top to bottom, top is V, down is U. If logarithm is here, so it deal as a U, and algebra above is deal as a V. So that is why this is U and this is V. And now I'm starting. We have to prove this connection. Make A alone. Okay. And before I start, formula UV, U copy, integration of V minus a sign of integral. Here bracket start, here ends again V integration into differentiation of U function. So let's apply it. So I'm applying this formula here. So first of all, logarithm copy. Integration of this. What is integration of this? Okay, I'm showing first of all. Big sign of integral, again integration of 6x into differentiation of log of x. And dx must be there, but before bracket is there. Equal to 4. So students, here I got log of x. Here increase the power by 1 divided by same. Again, increase the power divided by same. Here 1 by x and dx equals to 4. So this I'm writing 3x to power 2 time to logarithm of x. Here this cancellation, 3 and this cancel. So we got a 3x, and if we integrate 3x to power 2 by 2. Let's check again. 3 is there, and x, so x squared by 2, correct. Okay, limits are 1 to a is equals to 4. So what is my job to target? Is this my target to achieve? And when you start, so best way is write this way, e to power. So 1 by 6 in the bracket 5 by a square plus 3. Okay. All right. So let's apply the limit, students. So when I plug in a, so I get a 3a squared time to log of a minus 3a squared by 2. Upper limit done. Minus. When I plug in lower limit, log of 1 is 0. So this complete 0. And I'm getting here 0 minus 3 by 2 equals to 4. Okay. Then after that, what's the next plan? Even if I take the logarithm of this side, student, just sake of understanding, if in case you make it easy for yourself. So log of a is log of a, but log of this exponential cancel, and this 1 by 6 time to 5 over a square plus 3. So you can guess our target. This is ln a, we have it. And let's try to do it. 3a square log of a minus 3a square by 2 plus 3 by 2 is equals to 4. Okay, after this, I will bring both values on the other side. 3a square ln a alone, and these other values I'm going taking on the other side. So 4 minus 3 over 2 is turned to be 5 over 2. It means when this goes there, so I'm getting 3a square by 2 and plus 5 over 2. This is clear. After this, if you look at carefully, we have to if we divide by this a 3a square, we don't need here. So divide the whole equation by 3a square. So I'm getting ln of a. Okay, here I'm getting what, students? So when this 3a square come at this level, so 3a square already present, 2 is present, and 3a square comes extra. And 5 by 2, and I get 3a square extra. This cancel out. We get a 1 over 2 and plus 5 over 6a square. You can see that we are reaching our target, okay? ln a is clear. And if you look at carefully, we can take 1 by 6 common. You can see 1 by 6 common. So I take 1 by 6 common. If I take 1 by 6 common, I get here 5 over a square and plus 3. Why 3? Because, or you take an LCM, even no problem at all. So LCM 6, so we must have a 3 on the top. This is done. And log of a. So it means even the top target is achieved, and now I can final form. I can say that take a this I can write. I said before, even the previous questions. For example, 5, we can write ln e to power 5. So k, we can write ln e to power k. You can check in calculator the upper part, students. Okay, so here I can write ln and e to power 1 by 6 in the bracket 5 by a square and plus 3. And this ln cancel out, and we have proved. So a is equals to e to power 1 by 6 and 5 over a square and plus 3, and target is proved. So I hope so the concept of the question is very clear, and let's go for next part. Verify by calculation, a lies between this. So I have two choices. So either I will bring this here or bring this on the other side. Both are okay. I'll give a name as function of f, not function of f of a basically, because a involved here. So I'm writing here e to power 1 over 6 and 5 over a square plus 3 negative a. So this equation I will copy 2 times, and 1 time both times I'm empty spaces, e to power 1 by 6 in the bracket 5 over bracket square plus 3 close bracket negative a. I'm bracket. So I'm putting 1 time 2 and 2 every empty space by 2. But first I will copy paste because I need second time. So now student, I'm putting here 2, 2 and 2. When I'm putting here 2.1, 2.1 and 2.1. Matter of typing in calculator. So first of all, I got a 5 divided by 4 plus 3. What answers turn to be into 1 over 6 and e to power this answer and negative 2. And I'm getting here, I'm getting 0.031. And same way, student, I can do the other one. So 5 divided by 2.1 square and plus 3. So into 1 over 6 and exponential to power and negative 2.1. And I'm getting this time negative 0.108 students as first positive and later on negative as sign changes. So root lies between 2 and 2.1. So I hope so point is clear. Let's last part of the question. Use iterative formula based on equation part 1, determine a to 2 dp, each result 4 dp. Final answer 2 dp, but each answer 4 dp. So students, we have to go back and see the equation which he talked about. He talked about this equation. Same thing we have already, which we have proved. So we will take that equation from here. This equation I will take from here. And I need it here. Paste here. Okay, so student focus here. I will write extra part here, n plus 1 under the subscript. It's called subscript, okay? And here, and I will write here also. The thing is that what is a a1 value? I will replace every n by 1. So it will become 1 plus 1. I got a 2, a2, and e to power 1 by 6 in the bracket 5 over a square. So square of this one, or I'm writing it in a proper way, 5 over a square plus 3 close bracket. And this is clear. Okay, so student, what to do onwards? What is initial value? We don't have take average of these numbers. So 2 plus 2.1 divided by 2, 2.05. And this initial value, I'm going to plug in it here. So 2.01. Now students, I'm going to find it. So 5 divided by, okay, I use it here. Exponential in power in fraction. In fraction, we have 5, and down we have a 2.01 to power 2 and plus 3. So if you check it, 1 minute, please. So I'm getting student first answer 2.0264, 4 dp. Now first I plug in N1, now I'm plugging in N2. When I plug in 2 here, I get a 3, so I'm getting A3. and e to the power 1 by 6. And best way, I think I should copy it from here. Saving the time, copy and paste here. Okay, but this value I will take from where? From here. So 2.0264. So I'm taking here 2.0264, and I'm getting the answer is A3 is 2.019697, sorry. So we have to check it 2dp, but 2dp still not match. So I'll go for N3. So A4 will become, so again, paste here, you know very well. Okay, so, sorry, this is so I will take this part again. Okay, this time again, I will remove this value, students, and I copy this value here. So I'm getting, students, what here? 2.0197. You'll give A4. A4 is, if I replace 20197. So we are getting here 2.0224. Now, student, is see, it is going to start matching now. One more term is enough. Because here slightly fluctuation, you see, slight fluctuation is there, but I think now it will cover up. So if I copy this complete, so here I got 5, and here I'm going to replace. Okay, 5, and here I'm writing a 5, 2.0224 square. I get A5, students. So A5 replace here 224. So my answer is turned to be 2.0213. Now see it start matching, and that's it. Our answer is finally 2.02. And I hope so the concept of the question is very clear. And question is completely over. Question number 10, a question and remainder we need to find when this divided by this. So let's start. So x cube plus 5x square, negative 2x and negative 15. So this multiply what? Give you this value, so x. And x multiply both values, I get x cube and minus 3x. Okay, and yeah, sign changes, this cancel out. I get a 5x square plus x negative 15. So this multiply what? Give you this value, so plus 5. 5 multiplies both values, so 5x to power 2 and 5 3 is a 15 negative. Sign changes, cancel, x left. But how to write fraction forms to, oh sorry, he's asking quotient and remainder. So remainder is x and quotient is x plus 5. But if you write fraction form, maybe we need down. So what is method? Start this one as a x plus 5 here in bracket, plus this remainder will go on top. And wait a minute. Okay. And what to write in denominator, students? In denominator, I will write as this one. So I think it's clear approach, clear idea. So this fraction, I got it finally. Mixed fraction is called. Okay, I think idea is very clear, and let's go for the next part. So this question, we have to do it. So differential equation, and x is 2y2 given, and our main job is to y square in terms of x. So y square is subject. So first of all, it means y, I must need left hand side. So first of all, you can see all x involved, this x involved, only one y. So this 6y will multiply left side. And sorry, dx, dy also we have. The rest completely go right hand side. And I got x squared minus 3 and dx. If you look at carefully, this is the same thing. It's the same thing we have done it. We divide this with this. And now we can replace this completely with this part, this whole thing. So you see, this is, I already planned. So copy, and I'm pasting here. Okay, this came here in the place of it, and now I'm doing integration of both sides. So integration of both sides, integral, and dx. Okay, is question, what is the next plan, students? I will split 6y here, dy. Here I'm writing separate x plus 5 dx. Here I'm writing separate because here we have to do some extra work. What is this differentiation, student? 2x. This is 0. We're looking for the 2x on the top. So 2 is not available. 2 divide and 2 multiply. Upper 2 will go inside. So I think the idea is clear. And now I'm going to further continue. So increase the power by 1 and divide by same. X become x squared by 2 and 5 become 5x. This 1 by 2 as it is into logarithm of, because 2 goes inside, and function down, differentiation up available. So I can write this plus c. This I can write left hand side, I can cancel. I got a 3y square. Okay, now this whole expression, equation, I will copy from here and move on next page. But look the condition, x2 y2. I will shift on next page, x2 y2. Okay, and basically here I printed actually, but I think okay now, and plug in x2 y2. So when I plug in x2 here, y2, y square 4, 4 is 3, 12. Here 2 square 4, 4 by 2, 2. 2 5s are 10. Half of logarithm 2 square 4, 4 minus 3, 1. Log of 1 is 0. This is gone. So don't waste time here. And C we got it. So C becomes 2, 0. Because C got a C 0. So final equation which I get from here is so we are getting 3y square is equals to x square over 2 plus 5x plus 1 over 2 log of x squared minus 3. Now this 3 will divide, when divided by 3. So what I'm getting, students, so x to power 2 by 6, 5 by 3 times to x, and 1 by 6 times to x to power 2 minus 3. So I hope so the concept is very clear, and let me check anything else. No, he said only make a y squared subject. So I think the concept is very clear and question is completely over. Question number 11, students, the topic is differentiation. Because he says that a curve has a maximum point at m. At m, x value is a. So we will do two jobs together. So when you replace dy over dx is equals to 0, and same time we replace x by a. So let's start. So because they're product, so I will do one by one. U copy v dash and v copy u dash. Dash means differentiation. So cos x copy, and what about this one? And plus then sine double x root into this one. So what about this derivative? So half goes down and the power sine double x to power become negative half into the derivative of the base, which is naturally cos double x into 2. 2 comes from derivative of angle. And what about this cos derivative becomes minus sine? So I'm putting, first of all, simplifying, then I do it. This 2 and this 2 cancel out, and I can say cos single x, cos double x over root of sine double x. Okay, and I think this card is clear, already clear. And now what about this one? So sine x into sine root double x. And here dy over dx. Okay, now I'm putting derivative is equals to 0. And I'm replacing x by a. So 0 cos a, cos double a, sine double a, minus sine a, and sine double A. Okay, this completely I'll bring left side. I mean to say copy and paste and go here. And this copy and paste will be here. In the middle equal sign. Now, so what to do? This multiply and sines root cancel out. I get a sine A and sine double A equal to cos A and cos double A. So now we have one choice, students. What is that choice is? You can see we have to make a tan and cos go under it. We'll get a tan double A. So tan A, it goes down. So I get a tan double A is equal to 1. And this part is clear. Now, student, after this, what to do? We have a choice here. We have to apply the fundamental law of tan. And what is fundamental law of tan? If you recall, so tan A plus A. Okay, I can replace here tan A plus tan A over 1 minus tan A times to tan A. So I'm replacing this value here. Tan A is already. So tan A, I got a 2 tan A over 1 minus tan square A is equals to 1. So tan A becomes 2 tan square A. And this cross multiply 1 minus tan square A. This goes there. I get a 3 tan square A is equal to 1. After this, students, what to do? We'll take this goes down 1 over 3 and tan square A is equal to 1 over 3. Take a root. We have did you mention any? We can see here, this is a positive answer, no negative answer. And even that is less than pi by 2. It's the first quadrant, we can say. So I will take a root of the both sides. Tan A is equal to 1 over root 3. And with tan positive, we'll take it here. So if we take this tan inverse, 1 over root 3 is giving us, this is basically it is 30 degree. So pi by 6. Pi by 6 is a 30 degree. And we got it. And he was asking find the value, exact value A. Done it. Now next part, region enclosed by the x-axis, the curve is rotated about 2 pi. Like we rotate if the region enclosed between x-axis and the curve is rotated 2 pi around x-axis. So what is the formula of y? So what is the formula of the volume, students? Basic formula of area is what? If you check about x-axis, x1 below, x2 up, and y dx. So same formula of the volume, only two changes are there. So x1, x2, y dx. Changes, I'm writing blue color, pi and square of y. So there's a change only. So I'm going to apply the formula. So go back on the top and get the x1, x2, and y square. So x1 is what, students? 0. And x2 is pi by 2. Okay, and equation you know very well. Equation I'm copying from here, which is a cos x root of sine double x. Let me check again. Yeah, correct. I'm going to cut from here, and 0 to pi by 2 is a little range. 0 to pi by 2. So I'm pasting here. Okay. So it means pi outside. So 0 to pi by 2. When I square this, I will get a cos square. When I square this, root will eliminate. I will get a sine double x. So now a difficult part, what we have, students? Difficult part is that we have a double and single angles. How to deal with that? So students, we have if you look at, we remember, sine, we have one formula only, sines 2 sine x into cos x. Basically, this half angle here and half angle here. Clear? So I'm going to apply this now. Pi outside, 0 to pi by 2, cos square copy, and here I'm writing 2 sine x into cos x. Okay. Now what to do, students? This cos into cos become cos cube. I'm writing now pi outside 0 to pi by 2, and I'm getting 2 outside also. This 2 I'm bring outside. And I got cos cube x, students, into sin x. Now, very interesting what to do. We know that cos derivative is sine. So we introduce, but minus sign, not that one. So I'm introducing 1 minus outside and 1 minus inside with the sign. I'll tell you later what's the reason behind. Okay, this is done, and 0 to pi by 2. Okay, basically because if you look at carefully, what is differentiation of cos? That is a negative sign. So we are looking inside sine because formula which I'm going to apply now is here. Function inside, it has a power and derivative also there. Okay, what we do, increase a power by 1 and divide by same. And this will eliminate and function will eliminate automatically. So the same function down and derivative available, function and derivative available, not down, sorry, both are same level. So it means, students, negative 2 pi outside and 0 to 2 pi. I can do directly now. Integration of this is cos 4 x by 4 and limit 0 to pi by 2. And this will eliminate automatically. Now we can do it now. This 4 comes out. So I can say here, I'm getting here, students, negative 2 pi by 4. Inside, I'm going to plug in, when I plug in cos pi by 2, okay, student, and a whole power 4. Then I plug in cos 0 and whole power 4. So if you look at carefully, this becomes outside negative pi by 2, and cos pi by 2 is basically, if you know, cos pi by 2 is 0. So this is 0. And cos 0 is 1, so we get this. So negative, negative, positive, so pi by 2 unit cube is a volume of my curve. If you rotate about, this is a curve. If you rotate, it becomes this shape. So about x-axis rotation. So I hope so the concept is clear and the question is completely done. And the paper is completely over, and best of luck for the coming exam, and pray for me. And assalamu alaikum wa rahmatullahi wa barakatuh.